be a formula. Any of the formulas in terms of like wind chill or compound interest, if you need them, I will give them to you. Those you don't have to remember. Distance formula is a fairly common formula that's used in lots of applications. I expect you to remember the distance formula. That's why I'm going to derive it and give you an idea of where it came from. That makes it much easier to remember. Makes it much easier to remember. Where the distance formula, I think that's the only formula in this chapter. So the distance formula basically is related to something that you probably have seen in arithmetic, and that is the Pythagorean theorem. The Pythagorean theorem says this: you have a triangle. That triangle is what we call a right triangle. So it's at like this room, and it probably isn't because most rooms are not square. The corners are usually not 90 degrees. They're supposed to be, but they're usually not. But you have this corner which is 90 degrees. The long side of the triangle is called the hypotenuse. The sides, the other two sides, are called legs. The Pythagorean theorem says that the square of the hypotenuse is equal to the sums of the squares of the two legs. No, because in this particular instance we're talking about squares, unfortunately. So it says, if I were to take a look at these legs right here, the square of this number is equal to the sums of the squares of those two. So if I square A, I square B, add it, it will be that length of that, the square of this number right here. It's Pythagorean theorem. So what does that mean to us? Well, I'm going to do something that we've seen, and we've seen rather frequently, and you have seen rather frequently, and I'm going to pick two coordinate points, x sub 1, y sub 1, a second coordinate point, x sub 2, y sub 2, and I'm going to draw a line between those 2 points. Now, we've seen that before. Well, when we're finding the slope of the line, the slope of that line is rise over run. So when we developed the slope formula, that's when we saw that formula. Now, how did we get it? Well, if you remember, we essentially created a right triangle where the distance on this side was the long distance, which is x sub 2, subtract the short distance, which was x sub 1. This distance here, the long distance is y sub 2, subtract the short distance, which is y sub 1. And then for slope of the line, we took y2 minus y1 over x2 minus x1, the good old rise over run. But now we're going to have a different purpose. Because this is a right triangle, which means that's 90 degrees, the distance between here and here, this is the hypotenuse of that triangle. I'm going to call it D for hypotenuse. These are the two legs. The Pythagorean theorem says this, is that the length of this one squared is equal to the sums of the squares of the two sides. In this instance, I called this line, the hypotenuse, d. So this is d squared. The distance here is not a in this instance, is going to be x2 minus x1 squared. This distance is b, so that would be y2 minus y1 squared. Now, I don't want d squared, that would be the distance squared. I want d. So what do? I unsquare it, which is the square root, yeah. What I do to one side, I must do to the other. I'm going to square root both sides. What is the square root of d squared? D. Now, because under this radical, this is an addition, that creates that radicand is a clump. I can't take the square root of these individually until order of operations says you have to square, you have to square, you have to add, then you can take the square root. So this then becomes x2 minus x1 squared plus y2 minus y1 squared. This is the distance between the coordinate point x1, y1 and the coordinate point x2, y2. And this is called the distance formula. That means if I have a formula, this guy becomes a plug and chug. If I know what the coordinate points are, I know what the distance is between the two coordinate points. It's a plug and chug.